This is section 3.4. This is a math lab. We're going to be playing around with modeling trinomials as binomial products. That sounds like something that you can't quite understand yet, but we're going to use some algebra tiles to see what happens when we make rectangles out of trinomials, essentially. So what they've started out with here is a question that just talks about the fact that in math, when you multiply two numbers, for example, if I multiply 13 times 15, that's represented as a rectangle. That's 13 wide, or 13 high, I guess, and 15 wide. And the answer you get if you multiply 13 by 15 is 195. If I was to break this into little cubes, and if this had better resolution, you would see it. This would be 13 little squares wide, and this would be 15 squares high, and there would be 195 of these tiny little squares throughout this diagram. So we're going to use that representation using algebra tiles for trinomials. So this may be even easier to understand than that first example. We're only going to use positive algebra tiles today. And the resolution isn't great here, but hopefully the sheet you have helps you follow along a little clearer. So we have this rectangle over here, and this rectangle represents the trinomial x squared plus 2x plus 1. Why does it? Well, we have an x squared. We should have two x's here and here, and we should have one little guy that's here. And again, we always want to force these into rectangles. It says write the side length on each side of the rectangle. The side length is, if you were to walk from here to here, if I can zoom in a bit on this. No. If you were to walk from here to here, how far would you walk? Well, you'd walk from here to here is x, plus 1 more is 1. So you would walk x plus 1. What about walking from here to here? Well, again, from here to here is an x, from here to here is a 1. In total, you would walk x plus 1. It says use the side length to write the polynomial as a product. The area of the rectangle is always the original polynomial, which is right here. Its length and width are the two things that we multiply together to get that area. And what do you multiply together? X plus 1 times x plus 1. If you remember back to our last section, we are actually taking this trinomial and factoring it into two brackets. The first bracket is an x plus 1, and the second bracket is an x plus 1. Now this next question says, sketch as many of the x tiles and the 1 tiles as you need to complete the rectangle to show this trinomial, x squared plus 3x plus 2. Now if you look here, we don't have enough. We have an x squared and two x's. I need an x squared plus a 3x plus a 2. So how would I add that? Well, if I was to add an x tile right here, to complete the rectangle, I would need two little guys down here. Do I have a rectangle with all the right pieces? Yes, I have an x squared, I have 3 x's, and I have a 2. Write as a product. What I want you to remember is that if it says write as a product, that means to write as length times width. That's what that translates into. And what else that's going to translate to in the future is that's going to translate into the factors. But for today, product means length times width. So how long is this? Well, if you were to start here and you were to walk all the way to that end, you would walk x plus 1 plus 1. You would walk x plus 2. If you were to talk about the width and start here and walk all the way down, you would walk from here to here, which is x, plus another one is x plus 1. So when it says write as the product, that means the length times the width. X plus 1 and x plus 2. Now, it doesn't matter who goes first. You could have put the x plus 2 here and the x plus 1 there. Doesn't matter. So, turn the page. For the next page now, you are asked to do a little bit more of the same thing, but a little more complicated. Sketch as many of the x tiles and the 1 tiles as you need to complete the rectangle to show this trinomial as a product. So this trinomial is x squared plus 4x plus 4. That's better. No, it's not. I only have an x squared, and I have 2 x's here. I don't have the 4 x's that I need. So I'm going to add an x to here, and I'm going to add an x to here. And if I do that, it creates space here that can be filled in nicely, if I drew better, using 1, 2, 3, 4 little guys. So now this does have an x squared, it has 4 x's, and it has 4 little guys. Right as a product, again, that means length times width. How long is this? This is x plus 2. And how wide is it? This is x plus 2 as well. So if I was to take this polynomial or this trinomial and write it as a product, that means that I have a length of x plus 2 and a width of x plus 2. These blanks are a bit big. All right, the next one says, sketch as many of these and these as you need to complete this rectangle to show a different trinomial. So you're allowed to make up whatever trinomial you want. So essentially, let's add a bunch of tiles, of x tiles and 1 tiles, so this guy is still going to be a rectangle. So I'm going to add, just because I feel like it, 1, 2, 3, 4 more guys down here. In order to fill this in then, I would need 5 little guys on the bottom. Let's first of all write what this guy is as a trinomial. He has an x squared. He has 1, 2, 3, 4, 5, 6 x's. And he has 1, 2, 3, 4, 5 guys down there. That is the trinomial. Let's write as a product. Write as a product means length times width. How wide is this? This is x plus 1. And this is x plus 1, 2, 3, 4, 5. The product is x plus 1, x plus 5. All right, next one says, use one of these x squared tiles, which is already given us, and as many x tiles as 1 tiles as you need, then sketch a rectangle to show a different trinomial. The wording of this isn't great, but basically we're going to build on him and add some x's and some 1's to make whatever trinomial we feel like. So I'm actually going to add, because I feel like it, 1, 2, 3, 4 guys there, and 1, 2. If I was to fill this in, I would need a bunch of little 1's down here. How wide is this? Well, this is x plus 1, 2, 3, 4. This is x plus 2. Let's write down what this trinomial is. Well, in the picture I have an x squared, and I have 1, 2, 3, 4, 5, 6 x's. And I have 1, 2, 3, 4, 5, 6, 7, 8 little guys. Write as a product now, that's length times width. I have an x plus 2 times an x plus 4, or x plus 4 times x plus 2. Doesn't matter. Part B. This rectangle represents the trinomial 2x squared plus 3x plus 1. What's the side length of each rectangle? Well, this is now x plus 1. So 2x plus 1. How wide is it? X plus 1. Write as a product, again, I just kind of have made a little note here that that's length times width. So 2x plus 1 and x plus 1. This next one, sketch as many x tiles and 1 tiles as you need to complete this rectangle so that this whole rectangle has 2x squareds plus 4x plus 2's. Now right now he just has, oh no, sorry, this one here, 2x squared plus 7x plus 3. I have 2x squareds, I only have 3 x's. and I need to have 7x's somehow. So you may have to play around with this, but if you do that, you're going to find that the only way it'll work, and there usually is only one way that it'll work, is to put those here so that you have space for 3 little guys over here. Let's write the product of that. How long and how wide is it? Well, this is 1, 2x plus 1, and this is x plus 1, 2, 3. So 2x plus 1 and x plus 3. This guy needs to be 2x squared plus 4x plus 2. And if you were to put these guys down here, the additional ones we need, wouldn't work. The only way it's going to work is if I add the extra 2x tiles I need over here, so that I have 1, 2, 3, 4 x's, and I have exactly enough room for the 2 little guys I need over here. What is the length and width? Well, this is 2x plus 2 long, and this is x plus 1 wide. 2x plus 2 and x plus 1. This one here, let's make a totally different trinomial built off of this. So what I chose to do is I chose to add 4 guys down here, and I chose to add 1, 2, 3, 4. And if I was to fill this in now, it would look hopefully better than that, but it kind of looks like that. This is now 2x, 1, 2, 3, 4, 5, plus 5. And this is x plus 1, 2, 3. Let's write down what our original polynomial is. Well, in this picture, I have 2x squareds. If I count my x's, I should have 11 x's. And if I count my little guys, I should have 15. The factors of that, or the product of that, or the length of width of that, is 2x plus 5 times x plus 3. We're going to do one more. And this next one on the last page says use 2 x squared tiles and as many x tiles and 1 tiles as you need to make. And again, we're going to make just whatever one we want. It doesn't tell us which kind. And I've just elected to add a bunch down here. And I'm just going to add 1 over here. 1, 2, 3, 4, 5, 6, chopped in half. Our little guys here. And you guys know by now that my drawing is not so hot. What's the polynomial? 2x squared plus, if I add them all up, I should have 13 x's, and if I add up those, I have plus 6. The length is 2x plus 1, and the width is x plus 6. So that equals 2x plus 1 times x plus 6. Now, part C is something I just want you to think about. We're going to talk more about that in the future, but I want you to look at the relationship between the numbers that appear. What about these two numbers and this first number? What about these last two numbers and this last number? What about some of the inside numbers and the middle number? I want you to explore that for a little bit. Write down what you think happens in this next spot, and then you can go on and do the assignment on page 21.